AC power, also known as alternating current, is constantly changing its polarity, whereas DC power, or direct current, is a more consistent delivery of voltage and can be displayed in a linear fashion. Alternating current is what we use all across Australia, as it is much easier to deliver over large distances as there is only a small voltage drop. Additionally, it is much safer than DC power. Since the power is always changing its polarity, it gives you a better chance to pull yourself away from the electrical source, possibly saving your life. As well as this, it is easy to change its voltage up and down, making it perfect for general household appliances such as microwaves, fridges, and TVs. But how does it work? Well, AC power is generated by converting mechanical energy to electrical energy. This is done by rotating or oscillating a coil inside of a magnetic field, leading to directional current as the coil spins. This forces electrons to move one way, then the other. This can be displayed using an AC sine wave. The sine wave contains many key components. We have the maximum and minimum voltage on the y-axis. The period shows how long it takes for the wave to complete one oscillation, and the wavelength displays the distance between two consecutive peaks or troughs. Amplitude refers to the peak voltage, and the peak-to-peak voltage is what it says, the voltage from peak to peak. Lastly, the RMS, or root mean square, which is a steady voltage or the equivalent DC voltage. This can be calculated by dividing the peak voltage by the square root of 2. The equation for a sine wave is shown on screen. V equals A sine omega t minus theta. A represents the amplitude of the wave, and that weird W is omega, which can be calculated by 2 pi multiplied by the frequency. T stands for time, and theta for the phase angle of the wave. And that's it, the basics of an AC sine wave. Now have fun on your electrical journey.